Welcome back to Eagles Edu Concepts. In this video, we are looking at Grade 12 Mathematics by the Examination Council of Zambia, and this is a paper 1 topic. Motion time graphs is usually question number 23 in your exams. If you are visiting this channel for the first time, don't forget to click on the subscribe button. What is a motion time graph? A motion time graph is usually a plot of velocity against time. If it's a plot of velocity against time, then it will be called velocity time graph. If it's a speed against time, then it will be called a speed time graph. So we are saying a motion time graph is usually a plot of velocity against time. So that means that the quantity that is mentioned first goes to the y-axis, and the one that is mentioned after the word against goes on the x-axis. So this knowledge will also help you in other science subjects where you are required to plot a graph. So the quantity which is mentioned first goes on the y-axis, and the quantity which is mentioned after the word against goes to the x-axis. Hence, this one is called the velocity time graph. So it is plotted on the Cartesian plane, or what we call the x or y plane. All right, let's look at the terms associated with motion time graphs. Number one, we'll look at distance. So with respect to velocity time graphs, distance will be defined as the area under the graph, and the SI units is meters. Displacement will be defined as the distance in a specified direction. The SI units is also meters. In terms of calculations, distance and displacement is just the same. In terms of calculations, distance and displacement is just the same. However, there are a few differences which you would love to explore. The other term is speed, which is defined as the rate of change of distance. The SI units is meters per second. We also have velocity, which is the rate of change of displacement. The SI units is also meters per second. In terms of calculations, speed and velocity is just the same. Let's have a look at the sections of a velocity time graph. A velocity time graph basically has these sections. So it has got a section where there is a diagonal-like line facing forward, and this one is called a positive gradient section. So positive gradient section will simply indicate increasing velocity. Then we have a flat section. A flat section will simply mean constant speed, which will translate into zero acceleration. Then we also have a diagonal-like line facing downwards to the right here. So this one will be called negative acceleration, or what we call retardation. This simply means that the velocity is decreasing. All right, let's have a summary here. So section of the graph A here, you can see the gradient is positive. So gradient is simply the change in y divided by the change in x. So the gradient is positive in section A. So when the gradient is positive, it means that the velocity is increasing, and therefore acceleration is also positive. In section B, when the gradient is zero, because it's a flat section, like we earlier said, so it's a flat section, so it's constant velocity, which means zero acceleration. Then we have C, which is negative gradient because it is facing downwards, then decreasing velocity, which means it is negative acceleration. All right, so these are the important sections of the graph. Now let's look at how we can determine acceleration. First and foremost, acceleration is simply the rate of change of velocity. The SI units is meters per square seconds. Meters per square seconds. Now the formula for acceleration is given by A is equals to V minus U over T. Now this V simply means final velocity. So this is the velocity that an object is going to have before it goes to rest. Then u is initial velocity. So this is the velocity which an object has when it is starting from rest. So this is the velocity that an object has when it is starting from rest. Then this t is simply time in seconds. Okay, you also have to note that acceleration with respect to the velocity time graph, which can also be called speed time graph, is given by the gradient. Okay, so you find the gradient of a given slope, you find acceleration. Okay, therefore we are saying acceleration can also be found by the gradient slope using the formula y2 minus y1 over x2. Okay, so this is the formula here. We're saying y2 minus y1 over x2 minus x1. This can be translated into v minus u over t2 minus t1. Now let me just explain this one. So if you look at this point, this is where the initial velocity is. So this is the 0, 0. Then this point here, this is 10, 15. Remember, x, y. So this is 10, 15. So this one is the x1, y1. Then this one is the x2, x2, y2. So you get these coordinates, substitute them into this formula, you find acceleration. All right, let's look at an example. Okay, so from the speed time graph below, determine acceleration and retardation. So this is the graph that has been given. Now we know that acceleration is represented by this line here, and it can also be represented by this line, because positive acceleration, then negative acceleration is what we call retardation. So they haven't specified, unless if they specified. So in this case, we are required to find for this part and this part. Okay, let's see how we can demonstrate. So we can use the formula acceleration is equals to v minus u over t. So we substitute our v is final velocity. So it started from 0 all the way up to here. That's where it stopped. So here, when you check, this is 15 here. So you put the 15 minus initial velocity, which is 0 here, then over t. So from where it started from up to here where it ended, you can see the time is 10. So it will be divided by 10. So if it's 15 divided by 10, you find 1.5 meters per second. Or you can use method 2, where we say acceleration is equals to gradient, which means that acceleration is actually going to be y2 minus y1 over x2 minus x1. So this is our x1, y1, and this is our x2, y2. So y2 is 15, then y1 is 0. Then x2 is 15, then x1 is 0. So this one will still be 15 minus 0 over 10 minus 0, and we'll still get the same answer. All right, so you can pause and just give it a try and find for this one. This one here, since it will start from here, this one is going to be our x1, y1, which will be 20, 15. Then this one here is going to be our x2, y2, which is going to be 30, 25. Okay, you can give it a try and see what answer you're going to get on that point. Now let's deal with retardation. So like we said, by definition, retardation is simply negative acceleration. So even the formula of the retardation is equals to negative a. So in order for you to know the retardation, you first have to find acceleration. So acceleration is equals to v minus u over t. So you substitute. Now, because it is starting from here, going down, so this is our initial, and this is our final. So our initial velocity here is actually 20. Our initial velocity is 25, and our final here, when you check, it is 0. So this it will be 0 minus 25. Then time, since from here, that is 30 all the way up to 50. So you subtract 50 minus 30, which will give us a 20. So when you divide negative 25 divided by 20, you're going to find negative 1.25 meters per square seconds. Now, retardation is equals to negative a. So when you put your acceleration, which you have found, it will be negative times negative, and you find your answer as positive. So the moment you put retardation in front of the answer, it means you lose the negative, and therefore retardation is given as a positive value. So that is about acceleration on the speed time graph. Let us now look at determining the distance under the graph. Now, distance traveled is given by area under the graph. So to determine the distance under the graph, simply divide the graph into non-regular shapes. The commonly used for regular shapes are, number one, we have the rectangle. Now, the rectangle is given by the formula. So the area of the rectangle is length times breadth. So the length is the longest side and the breadth is the shortest side. So to find the area, you just need to multiply length times breadth. So when you find the area, it simply means that you have found the distance. So whenever you've been asked to find the area, to find the distance, just find the area. The next shape that you have to know about is a square. Now, a square is also a four-sided polygon which has got all the sides the same. So it only has length. This one is length, this one is length. So the formula will be area is equals to length times length, which will be area is equals to L squared. The next shape is a right-angled triangle. Now, this right-angled triangle, it can face in any direction as long as one of the angles is actually 90 degrees. And this side here is called the length, okay? The length or the base, the length or the base. Then this other side will be called the height, which is h. As a result, the formula will be area is equals to half base height. So half multiplied by this multiplied by that. The other shape that you have to know about is actually what we call a trapezium. Okay, now a trapezium here, a trapezium has got these sides. This shorter side will be called A, then the longer side from one end to the other end is called B. Then the perpendicular height, if it's not there, you can draw it yourself. It will be called the height. So the formula will be area is equals to half, open brackets, A plus B, close brackets, H. So once you know how to come up with these shapes, then determining the distance under the graph will be simple and straightforward. Let's look at the question. Okay, so here it says, the graph below shows the movement of a Toyota Hilux from Zambia to Zimbabwe. From the graph, determine the total distance traveled by the Hilux, and B, the average speed of the Hilux. Now, this graph here, initially, you won't have these things, these dotted lines here. So the first thing you have to do is identify the shape. So when you move from there all the way up to here, you can drop your own line. This line wasn't there, so you can drop your own line and you form the what? A triangle, a right angled triangle. Then when you check this one, this from here to here is shorter, and from there to there it's longer. So when you look at this one here, you know that you have formed a rectangle. And here, when you look at this one, this distance from there to there, you know it's A. Then this one from there all the way up to there, you know that this is B. Then from here to here, you know that this is what? H. Okay, so this is a trapezium here. Then D here, when you draw a line, you will find that you also have a what? A right angled triangle. So once you have the ability to come up with these shapes, you make these shapes yourself. Like I said, these were initially not there. I had to draw them. So just make these shapes. So your aim will be actually to discover, can I make this shape out of this graph? Any of these shapes are going to be useful. Now, it's not all the time that you're going to have all these shapes. Sometimes you can just have maybe a triangle and a rectangle, or maybe you can just have a trapezium on its own, but I had to include all these here so that you can learn. All right, so we begin. So this is how it is done. So for the first one, this is the area here, okay? So area is equals to half multiplied by base multiplied by height. So base is from there all the way up to there, which is 10. Then the height is from there all the way up to there, which is 15. And you have found for that one. So you have found the area for this right angle triangle. Then you go to B, which you can do the same also. So B, from here all the way up to here, you discover that it's 15. So your length is 15. Then from here, from 10 to 20, meaning you have to subtract here. So this one will be 20 minus 10, which will be 10. So you know this is 15, this is 10. So from the formula, we know that the area of B is equals to length times breadth. That is where we're getting the 10 times 15, and we have the 150 meters. We proceed, we look at C. So C, this one, as you can see, it's a trapezium because it has got A, B, and height there. So you know that the distance for A from there all the way up to there, it's 15. So your A is 15. Then from there all the way up to the far end here, it's actually what? 25. So from there to there, it's 25. Then from 20 to 30, you just need to subtract here. 30 minus 20, you have 10. So the height is 10. And you substitute into the formula which says area is half A plus B then H. So your A is 15, your B is 25, then your 10, and you come up with your 200 meters. Okay, you deal with the right angle triangle now. So also here, the base from here all the way up to here, from 30 to 50. So we just subtract 50 minus 30, which gives us 20. Then from there all the way up to the far end is 25. So this one is going to be half multiplied by base multiplied by height, which will be half multiplied by 20 multiplied by 25, and to give us 250 meters. Okay, then to find the total distance, you just have to add everything together now. Total distance, you add everything and you come up with 670 meters. So average speed will be given by total distance divided by total time. So the total distance, this one, and the total time, the time at the far end there, you punch on your calculator, you find an average speed of 13.5 meters. Conclusion. Once you know the following about the graph, you are going to be successful in answering all questions that will come in the exam. Remember, it is usually question number 23 in the exam. So know that gradient represents acceleration. So if you want to find the acceleration from the distance, the speed time graph, just find the gradient. The flat section simply means constant speed, meaning zero acceleration. Then negative gradient simply means deceleration or negative acceleration, which is called retardation. So distance is simply found by dividing the sections of the graph into non-regular shapes such as triangles, rectangles, squares, or trapezium. And whenever you're finding the distance, just determine the area, and that's it. With this knowledge, you will be able to answer any question that will ever appear in your grade 12 final examinations or GCE. Thank you so much. Till next time.